Hello students, today's topic of the day is the concept of limiting reagent. The concept of limiting reagent means when we have two or more components in a particular reaction and they are not present in the stoichiometric ratios, then we have to use the concept of limiting reagent. In simple words, it means that one of the component is present in more amount and other component is present in less amount. So that is known as the concept of limiting reagent. So for the very first point, that when we have to apply the concept of limiting reagent, so we have to apply the concept of limiting reagent when the weight or when the moles or when the amount of more than one reactant is given in the quotient. For example, let's take we are having N2 gas plus 3H2 gas giving us 2NH3 gas. Now as per the stoichiometry we know that 1 mole of N2 will react with 3 moles of H2. As per the stoichiometry this is very clear that 1 mole of N2 will react with 3 moles of H2 to give 2 moles of NH3. But let us suppose they have given that we have 1 mole of nitrogen and 4 mole of hydrogen. Let us say 1 mole of nitrogen is given and 4 mole of hydrogen is given in the quotient. In such case what will happen? So in such case once the reaction is over, entire N2 will be consumed, and as 1 mole of N2 requires 3 moles of H2 only, so out of 4, 3 moles of H2 will be used and 1 mole of H2 will be left in excess. And how many moles of NH3 will be formed? So amount of product is always formed based on the amount of the species which is present in lesser amount. So N2 is present in lesser amount. So we can see that 1 mole of N2 when it is consumed will produce 2 moles of NH3. So 2 moles of NH3 will be formed in this case. So the limiting reagent means the species which is present in lesser amount. So limiting reagent is what? Limiting reagent means the species present in lesser amount. The species which is present in lesser amount, that is known as limiting reagent, and the other one will be known as excess reagent. So excess reagent will be species present in excess amount. Species present in excess or more amount. So in this example, the example which I have taken, in this case N2 is our limiting reagent and H2 is our excess reagent. Now they can also ask how much amount of excess reagent will be left once the reaction is over. So we can see in this case 1 mole of excess reagent is left. Now there is a simple trick to find limiting reagent. How to find limiting reagent? Trick to find limiting reagent. So what you have to do, you have to find the ratio of moles given upon the stoichiometric coefficient. Moles given upon stoichiometric coefficient, and the one which is having lesser value of this ratio. Lesser value, this component which is having lesser value of this ratio will be our limiting reagent. For example, this example let's take, we have 1 mole for N2 we can write, we have 1 mole of N2 given and coefficient is 1, so ratio is 1. For H2, 4 mole of H2 is given and ratio stoichiometric coefficient is 3, so it is 1.33. So we can see this is having lesser value, so this will be our limiting reagent. Now we can also write this in terms of volume. We can also write in terms of number of molecules. Let's take the case in which volume is given. So for example, let's say we have a reaction like H2 gas plus Cl2 gas is giving us 2HCl gas. Now let's say we have 11.2 liter of H2 and 12 liter of Cl2. In this case we have to find the excess reagent, which reagent is excess. Second, we have to find amount of, or let's write volume of HCl produced, volume of HCl produced. Third, we have to find the volume of excess reagent left, So we can see that 1 liter of H2 will combine with 1 liter of Cl2. If you use the formula, so if you apply for H2, it will be 11.2 divided by 1. In place of moles, we can also use volume as I have said earlier. For Cl2, we can write this will be 12 upon 1. And we can see it is very clear that the ratio is lesser for H2. So H2 will be our limiting reagent. So if H2 is limiting reagent, other one, that is Cl2, will be our excess reagent. Now we'll use stoichiometry. As per stoichiometry, 1 liter of H2 will react with 1 liter of Cl2. It means 11.2 liter of H2 will react with 11.2 liter of Cl2. It means this H2 is completely consumed and Cl2 out of 12 liter, 11.2 liter is used. So how much will be left? So 0.8 liter of Cl2 is left. Now, how much HCl will be formed? So 1 liter of H2 gives 2 liter of HCl. So 11.2 liter of H2 will give 22.4 liter of HCl. This point should be kept in mind that the species with respect to which we have to calculate all the amounts, that is the limiting reagent. In this question, as H2 was limiting reagent, that's why I have said that 1 liter of H2 will react with 1 liter of Cl2. And that is why 11.2 liter of H2 will react with 11.2 liter of Cl2. And 1 liter of H2 will produce 2 liter of HCl. That's why I have written 11.2 liter of H2 will produce 22.4 liter of HCl. Now second question is how much volume of HCl is produced. So in this case 22.4 liter of HCl is produced. And how much volume of excess reagent left? So 0.8 liter of excess reagent is left. This is example 2. Let's take example 3. Example 3 is 1 liter of CO2 is treated with coke and temperature is such adjusted that total volume after the reaction is 1.4 liter. Find the composition. In this case, you have to find the composition, that if 1 liter of CO2 is treated with coke and they are reacting, so reaction will be CO2 plus carbon will give you 2CO. CO2 is a gas, carbon is solid, and CO is a gas. So we have to find the composition once the reaction is over. So this first point is very clear, that if 1 liter of CO2 is reacting, and let us suppose that it is completely reacting, then the total volume of CO produced will be 2 liters. If 1 liter of CO2 is getting consumed, then as per the stoichiometric coefficient, we can see that 2 liter of CO will be formed. And if 2 liter of CO was formed, then the total volume once the reaction is over should be 2 liter. But in the question they have said that final volume is not 2 liter, rather it is 1.4 liter. This simply means that CO2 is not our limiting reagent. And if CO2 is not limiting reagent, it means CO2 is our excess reagent and carbon in this case is our limiting reagent. So whatever carbon is present that is completely consumed. Now, out of 1 liter, some X amount of CO2 is getting consumed. So let's say X liter of CO2 is consumed. So once the reaction is over, volume of CO2 left will be 1 minus X liter. And 1 liter of CO2 produces 2 liter of CO. It means X liter of CO2 should produce 2X liter of carbon monoxide. So total volume, if you ask, that will be equal to 1 minus X plus 2X, and that is given as 1.4. It means X will be equal to 0.4. It means volume of CO2 once the reaction is over, that is 0.6 liter, and volume of CO once the reaction is over, that is equal to 0.8 liter. So final composition of the mixture will be 0.6 liter of CO2. Let me write over here 0.6 liter of CO2 and 0.8 liter of carbon monoxide. This is our answer to the question. So I hope the concept of limiting reagent is clear to all of you. If you are understanding the topics, then please give a like. And if any part is not clear, then you can comment and tell me which part is not clear, so that in the coming videos I can clarify those doubts, or we can have a doubt session in which I can clear all the doubts which are there in the comment section. Thank you.